Hey y'all, are you there? Can you all see my screen?
Yes.
Yes.
Very good. Okay, so I worked on your test. And so Thursday, that's 1 week from today, we will have a test during class. It will be at 12:30, start right on 12:30. It will be a generated test from Connect. So in other words, you will go to the Connect website. You will, just like your homework, see what it says, test number 2. You will have, it will be timed, and you'll be given an hour, 15 minutes, and it will open up exactly at 12:30. Then you're going to be able to work that test. You'll be able to use anything you want. You want PowerPoint, you want open book, you want whatever to work that test. Excel is in there, and you'll have an hour and 15 minutes to do it. And everybody will have a different test. It'll be the same sort of problems, but they will be different numbers. And what we'll do is we'll have everybody just submit automatically at the end of the class period. Is there any questions about that? I feel very lonely.
Nope,
No.
I'm good.
Okay. All right, so let me show you like in Connect. It'll be very familiar to you. You're just gonna go to Connect, and you can see my me on the internet, right? Everybody can?
Yes.
Okay, so you just log on to Connect, and you go to your site. You guys are the 12:30 class. I got a whole bunch of stuff up here, but you'll see your own site, and you can see here I've already created it. It's already there, exam number 2, and you'll just click on it, and it will be in multiple choice form, and it is 22 questions as opposed to 24. So you should have really no problem getting through it. All right, any questions about that?
No, ma'am.
I'm not going to open it up so you can't see it, but it comes directly off the Connect test banks as well. So that it should be pretty familiar to you. So whenever you take the test, you'll be able to use the cheat sheet that's listed, and I'll actually have the cheat sheet up there, and you'll have that at your disposal. You'll have Excel at your disposal if you want to use a calculator instead, whatever. It doesn't matter to me. You can use your book as well, but I don't really think the book will help you that much, but you can get through it. In an hour and 15 minutes should be really easy to get through 22 of these in an hour and 15. Is there any questions about how that will go?
All the questions are just numerical problems, right?
Yeah, they're all numerical.
Okay.
There's just problems. There's no definitional types of things, no institutional knowledge at all, just problems.
Okay.
And they are in multiple choice form.
Okay.
All right, any other questions? Okay, well then I'm just going to work problems. That's all I'm going to do. And we can work through, I think we basically worked through most of the PowerPoint problems. And so I decided I would pull up, if I can, pull up an old test to kind of work through one. Let's see. Okay, so can y'all see the whiteboard better today? My 447 class thought that like turning it so this window kind of makes a problem. And it's sort of dark in here now, but does that help you guys see it? And I'm gonna go ahead and write on it. And it varies based on the time of day too, because in the morning, the sun is coming into the windows in a different way than it does as we get closer into the afternoon. So anyway, I'm gonna go ahead. You can see the my screen up here. Set you can see the test. It says
Yeah.
version 1. Okay, good. It says 12 years ago, you deposited $3,400 into an account. Okay, so I'm going to be careful here. 12 years ago, I deposited $3,400 into the account. 7 years ago, okay, so 7 years ago, minus 7, I added another $1,000 into the account. You earn 8% compounded annually for the first 5 years. Wow, this is hard. 8% compounded annually over this period. All right, and then 5.5% compounded annually for the last 7 years. Okay, so here's time period 0, and their different interest rate is 5.5%. All right, so this is kind of complicated here. How much money do you have in your account today? This is a future value question. My values are all to the left of where my question is right here. So these are two separate future value questions. First, we have to find out how much this $3,400 is going to grow into by year. I guess it'd be 7 years from in the past. And then we're going to combine whatever that future value is that we get to 1,000, and we're going to let it grow at 5.5% interest for 7 years. So this is a two-stage problem. The first one, where we're finding the future value over a 5-year period, is going to be equal to the present value, which is 3,400 times 1 plus the interest rate we're applying is 8%. We're raising it to the n, which is the number of years, times m. M is the number of times compounded, which is once per year. So this is going to be raised to the 5 times 1, and we're dividing it here by 1. We're going to get a number there, and I'm going to get Excel out to get that number to make it easier. Okay, so my first calculation, I'm taking future value, 8% annual interest for 5 years, no payment, and the present value is $3,400. This will give me the future value of that first deposit right here. So we're going to add to that $1,000, $499.72. All right, then we have to take that value, find the future value over 7 years going forward, and that's present value is going to be $5,995.72 times 1 plus 0.055. It's annual compounding, so we're dividing that interest rate by 1, raised to the 7 years times 1. That will get us to today. All right, so I'm going to take future value. Interest rate is 0.055. Number of periods is 7. There is no payment. And we're going to add together I'm going to put a minus sign in cell reference so I get all of the decimals there, turning it positive for me, and add to that 1,000. So that is actually my number here, 5,995.72. It gives me $8,721.84 to be exact. And the closest answer I see here is answer E. And we can see we're some pennies off. Does anybody have any idea why the pennies could be there? I mean, we're talking about a little over 10 cents. Anybody have any idea why my answer is different than their answer?
Decimal places.
They're probably using a calculator, is my guess, and they are rounding off, and they're having to round off not just one number, but two numbers, and which is, so you're getting some rounding error there. And when I cell reference that, I'm getting it right on the money. So that's the difference, right? Let's see. So whether you use a calculator or Excel, just note that there could be a small amount of rounding error depending upon what you're using and what the creator of the test were using as well. All right, so here's another one, another question. It says, McClary Tires just decided to save money each year for the next 4 years to help fund a new building. If it earns 6.5% on its savings, how much will the firm save at the end of 4 years? So they give me a table to work off of. And it's giving me a timeline, basically. It's saying that they're going to save in 1 year, 20,000. In 2 years, 24,000. In 3 years, 28,000. In the 4th year, they're going to save 32,000. This is a mixed cash flow. None of those values are the same, so it is not an annuity. We're going to be forced to set up a little table in Excel and actually compute via table. So it says we're saving for a new building that we want to build in 4 years, interest rate 6.5%, and we're valuing this set of savings over at the 4th time period. All right, so if we were doing this by hand, this is clearly a future value question. And the reason is because the question is actually to the right of my numbers here. All right, so future value of $20,000 is 20,000, which is the present value, times 1 plus 0.065. And we're going to raise that to the 1 to 3rd power. Then we're going to add to that the future value, which of 24,000 over 2 years. So my present value is 24,000 times 1 plus 0.065. Raised to the 2nd power. So we're saving it in the account for 2 years. And then we've got my 3rd value is 28,000 times 1 plus 0.065 raised to the 1st power, because we're allowed to actually have that in the account for 1 year, earning interest. And then finally, 32,000, in which we don't get any time to earn interest. So it's raised to the 1 plus 0.065 raised to 0 power. Okay, so that would be what we do to solve it by hand, but I would recommend going to Excel, setting up Excel here. Time period 1, 2, 3, and 4. Time period 1's cash flow is 20,000. So here are my present values, or what I'm calling cash flows. And here's 24,000, 28,000, and then 32,000. I'm going to get this all in the same formatting so it doesn't bother me here so much, not to have some commas. Commas in there. Okay, my interest rate is 6%, sorry, 6.5%. And I'm just going to copy that down for every cash flow. And then I'm going to put in an NPER, which is basically my exponent on each one of the terms. So that first cash flow, which is 20,000, should be associated with a 3. The second one, which is 24,000, should be associated with a 2. And then we go down 1 and 0. Then we are calculating the future value. So I'm going to hit equal future value, open up the parentheses. My interest rate is, I'm clicking on the 6.5%, cell referencing. My number of periods, I'm going to click on the 3. There's no payment, and the present value is 20 grand. Close up the parentheses, and I get the value of, if you saved $20,000 a year from now, it would be worth to you $24,158.99 at year 4, which is 3 years from the time you saved it. Copy those down, sum them up, and you can see when I double click here, makes the column wider, and I get an answer, 113,200 and exactly 39 cents. So that's answer D. Any questions so far? Okay, so Skyline Industries will need $1.8 million 5 years from now. So 5 years from now, Skyline needs 1.8 million. And currently the firm has some extra cash and would like to establish a savings account for this purpose. The account pays 5.25% interest, compounded annually. How much money must the company deposit today to fully fund the equipment? And that's with one single lump sum payment into an account. So they're asking what's the present value at time period 0. All right, so math here, present value is going to be equal to the future value, which is 1,800,000 divided by 1 plus 0.0525 raised to the 5th power. I go into Excel, I hit equal, present value, open up the parentheses. We're talking about 5 years is the NPER, or sorry, the rate is 0.0525. The number of periods is 5 years, no payment, and the future value is 1,800,000. So we get an answer of 1,393,676.52, which is answer number D. Okay, here's another one. Any questions about that one? That was a pretty easy one, number 4 was. Good to go? All right, Doris Fashions has just signed a $2.2 million contract. The contract calls for a payment of 0.6 million, that's 600,000 today. All right, so let me write this down. So today they get 600,000. In 1 year, they're going to get a payment of 800,000. And then in another 800,000 2 years from today. So that's actually 2.2 million when you just add them up, but that's not really what the value of the contract really is. So this is exactly the same thing that goes on with baseball players and basketball players. They talk about the contracts they're signing, and they're usually just adding up the total commitment over whatever period of years they're actually committed to playing. So when they say it's a $2.2 million contract in the news, all they're doing is adding up 600,000 plus 800 plus 800, and they come up with 2.2. It's not really worth 2.2 though. It's actually something less because we're not getting these two $800,000 payments until in the future. So this has got an 8.2% interest rate. And the question is, what's the contract worth today? So they want to know, what is the contract worth at time period 0? So this is going to be a present value calculation because all my numbers are basically to the right of where we want to value. We're going to take this first value, which is 600,000. That is going to be 600,000. Our future value divided by 1 plus 0.082 raised to the 0 power. That is $600,000. Plus then future value of 800,000 divided by 1.082. We're bringing it back 1 time period. So we're raising that into the first time period. And then second is our last cash flow of 800,000 divided by 1.082. And we're going to bring it back 2 years. So we're going to raise that to the 8th power. This is another one I would set up in a table. And the reason is because this is a mixed cash flow. There's a couple of ways we could solve this because I also see an annuity of 2 years. So I have to think if we could actually just use an annuity. So I'm going to show you several ways to do this. I'm going to do it like you always can get it done, and that's setting up a table, time period 0, 1, 2, and then the cash flow, which are future values, or what I call cash flows. That's 600,000 at time period 0. It's 800,000 in time period 1, and then 800,000 in time period 2. The interest rate, this is the annual interest rate, is 8.2%. And it's going to be applied to each one of the cash flows. And then the number of periods for that first cash flow is going to be 0 is the exponent. On the second one, it's going to be 1 and then 2. So I'm just matching up these number of periods is basically how far back in time we're going to have to pull the value to get to the point that we're actually valuing it at. So we're valuing at time period 0. 600,000 that we received today, we're pulling it back 0 time periods. Hence, NPER will be 0. And then if you receive 800,000 in 1 year, we're pulling it back to time period 0, 1 period. Again, exponent is 1, and the number of periods would be 1. And then the final one, 800,000, is being pulled back 2 time periods. So we've got our table all set up. Now all we have to do is hit present value. That's equal present value. Open up the parentheses. The interest rate is going to be equal to, I'm going to click on that 0.082. I'm going to click on the 0 for the NPER, so I'm cell referencing. There is no payment here that I'm using these as 3 distinctly different numbers. And then the future value, I'm going to click just right there on the cash flow itself. I'm going to copy that equation down, and I'm going to sum it up. And my column is too skinny, so I'm double clicking on it. That they might be saying that contract is worth 2.2 million, but actually in present value terms, it's worth 2,022,000. So that's not 2.2 million. And that is, looks like answer number B up here. Here's another way to do this. I see an annuity here, 2 values that are identical. And then I see 1 single present value, which is 1 number at the same period as I'm actually trying to value at. So I could do this. I could hit equal present value, open up the parentheses. The rate I'm going to put in as 0.082. I put in 2 for the number of periods, and then I put in a payment of 800,000. There's no future value, and the type I'm going to leave as type 0 because that first payment I'm receiving comes at the end of the first year. So it's an ordinary annuity. All right, so that value is 1,422,000. I need to just add to it my present value, which is 600,000. So I'm going to first of all turn around and put a negative sign in front of it so I can just add to that 600,000. And you can see I got the exact same answer. Any questions?
No, ma'am.
Thank you. I feel like the crazy lady. I think I can like turn my screen a little bit to the window, and I go to the window and I'm just looking out at my neighbors. Like, let me out of this place. And I'm sure they can hear me out there too. My walls are not that thick. So, all right. Any questions so far about these?
No, ma'am.
All right. So let's see. Number 6, it says you want to purchase a new condominium that costs $329,000. Your plan is to pay 20% down in cash and finance the balance over 25 years at 6.25% interest. What will your monthly mortgage payment be? Okay, so let's see what we have on the timeline first. First of all, I see the word monthly, so we need to keep in mind this is going to be in monthly terms. So this is going to be 25 years. We're going to finance this over, and you got 12 months per year. So 25 times 12 is our number of periods. The condo costs $329,000, but we're going to pay 20% down. So 20% down means that we're going to only have to finance 80% of 329,000. All right, so 80% of 329 means that our loan value would be $263,200. All right, that's how much loan value we'd actually have to borrow. And we're going to have a bunch of payments there. And so the big question is, what is your payment on this condo based on that information? And so it's asking us to actually compute that monthly payment, which is an annuity. Now, the interest rate that they gave us was 6.25%. All right, so I'm going to go straight to Excel. I'm just going to hit equal, PMT, open up the parentheses. The interest rate is 0.0625. That's annually, but since we are wanting a monthly payment, we need to divide that by 12. So we put that in monthly terms. Then the number of periods here is 25 years, but we have to multiply that by 12 because that's the number of actual months that we'll be making the payment. And then the present value, I could have done this. I could have put 0.8 times 329, or I could have put in my number 263,200. Either way, I have no future value, which would account for some balloon payment, which we don't have. It's fully amortized. And we're going to assume that this is an ordinary annuity. In other words, type 0. And we're going to hit enter. We're going to find out that our payment's going to be $1,736.25, which is answer A. Any questions so far?
Nope.
Nope, all good? All right, let's go to number 7. Planners Bank pays 5% simple interest on a savings account balance, whereas Centra Bank pays 5% compounded annually. If you made $12,000 deposit in each bank, how much more money would you earn from Centra Bank at the end of 20 years? So we got 2 banks and we're trying to compare. First of all, let's do the simple interest bank because that's easy. It's just computations where we're not going to need any Excel. We could do this on a simple calculator pretty easily. It's 5% interest and you put in $12,000. So your principal is going to be $12,000 plus then your interest is going to be 5% times $12,000. And remember, it's that $12,000 principal does not change. So in other words, we're not going to get to compound the interest to that. And so it's going to stay the same. And we're going to do this over 20 years. So this interest is going to be multiplied by 12, or sorry, 20. So 20 years? By 20 years. And so this is going to give our simple interest future value. I'm just going to do a little calculation over here on the side. I'm just going to hit equal 12,000 plus 0.05 times 12,000 times 20 years. And we would have exactly $24,000 in the bank that has simple interest at the end of 20 years. So we've doubled our money. That's good. The other bank is going to be a lot better. The other bank is going to offer you same interest rate, no different. You're still depositing the same amount of money, $12,000, but this is going to be compounded, and I believe it said annually. So if it's compounded annually, our computation is going to be, this is a future value question because we want to know what the value is on towards the right of this timeline. My value is actually on the left, so this is a present value. My future value then is equal to the present value, which is 12,000 times 1 plus 0.05 raised to the 20th power. And I can do that in Excel. I'm going to hit future value, open parentheses, interest rates 0.05, number of periods is 20 years. There's no payment here. There's instead just one single lump sum of $12,000 in present value. We will have $31,839.57 in that account. So I'm going to look at the difference between the two. And I'm going to put a minus sign out in front of this 31,839 because it's negative in my spreadsheet. I need to turn the number around so I can subtract it from 24,000. It looks like I made $7,839.57 more. So that looks like answer B. All right. Any questions?
Nope.
All right. You're scheduled to receive $7,500 in 3 years. When you receive it, you will invest it for 8 more years at 7.5% interest. How much will you have in 11 years? All right, so scheduled to receive $7,500 in 3 years. Oops. All right, when you receive it, you'll invest it for 8 more years. All right, so that would be out to year 11. So 8 years between. And the question is, and you're going to get 7.5% interest here in the interim. And the question is, how much will you have in 11 years? So this is again, a future value question. And take the future value where the present value is 7,500. I'm going to multiply that by 1 plus my interest rate is 7.5% annually. I'm going to raise that to the 8th power, and that will give me how much I will have in my account after 11 years. All right, putting that into Excel. Going to hit equal, future value. Interest rate is 7.5%. Number of periods, we have 8 years between our numbers. There's no payment, and there is a $7,500 present value. So we should have it in the account, $13,376.08, which is answer A. All right, you and your sister are planning a large anniversary party 3 years from today for your parents' 50th wedding anniversary. You have estimated that you will need $4,500 for this party. You can earn 2.5% compounded annually on your savings. How much would you and your sister need to deposit in one lump sum for the entire party? And that would be today, is what they mean. All right, so this party is going to be costing us $4,500. And that is 3 years from today. The interest rate we can get is 2.5% annually. And the question is, how much do we need to deposit today? So this is a present value question, since our values are to the right. So our future value is $4,500. Going to divide that by 1 plus our interest rate is 0.025 raised to the third power. All right, so I'm going to get into Excel. I'm going to hit equal, present value, open parentheses, interest rates 2.5%, number of periods is 3 years, payment is 0, future value is $4,500. We need to deposit $4,178.70. Okay, so next one, your grandparents would like to establish a trust fund that would pay annual payments to you and your heirs of $100,000 forever. All right, we didn't do one like this in class yet. This is called a perpetuity. When you see the term forever, it's a perpetuity. There's a separate formula for this, but it's very, very simple. Present value is equal to this perpetuity payment over the interest rate. And so the payment here is a payment into perpetuity. Which means forever. So there's really no Excel function for this. This is one you just do by hand. And so your grandparents wanted to establish a fund today, a present value lump sum, so that their heirs could actually get a payment of $100,000 forever. Interest rate 6%. So how much would they have had to deposit today? It would be $100,000, which is the payment that goes into perpetuity, all divided by your interest rate, which is 6%. Simple as that. All right, so I'm just going to take 100,000 divided by 0.06. They would have had to have, I think, got a minus sign in there by mistake. They would have had to have deposited into an account. Ooh, that's, I think, the sign of the devil. $1,666,666.67. That would be answer E. And if I were your grandparent, I would say I would want to change that payment to something different so my present value wasn't such a bad number. Don't want the sign of the devil in any of my numbers. Okay, so any questions about that one? That's a new one for us. All right, so okay, so 60 years ago, your grandparents opened 2 savings accounts and deposited $200 in each account. All right, so let me draw a timeline. All right, so 60 years ago. I'm going to put minus 60 here. 2 accounts. They put $200 in each account. One was with the Citibank at 3% compounded annually. So at 3%. And that was compounded annually. The second was Country Bank at 3.5% compounded annually. So the compounding is the same, but the interest rates are not. And the question is, which of the following statements is true concerning these accounts? All right, so let's first of all find out like what are they worth today? So time period 0 here. All right, so let's do a few, these are both future value questions. Hit equal, future value, interest rate of 6% on the first one, or sorry, 3%. 3% for 60 years, no payment, just a single deposit of $200 present value. That first account would be worth $1178.32. The second account is going to be worth at 3.5% over that same 60 years with no payment, and the present value still is $200. That second account's going to be worth $1,575.62. All right, so let's see which one of these answers is correct. It says Citibank, which is this first one. This is Citi. And here's Country Bank is the second one. Citibank account is currently worth $1,201.54. I do not believe that's true. B says the Citibank account has earned $211.19 more in interest than the Country Bank account did. Well, let's see about that. And no, Citibank did not earn more interest. They earned less. So I can actually not even do a calculation. So that can't be right. Number C, or letter C, it says the Country Bank account is currently worth $1,526.08. Not true either. Okay. It's worth $1,575.62. So that's not right. D says Country Bank account has paid $367.48 more in interest. Let's see about that. It's going to be equal to minus Country Banks. That turns it positive. And I'm just going to add then Citibank because it's already negative. So the difference there is $397.30, and I see that in answer E. So answer E is the correct answer. Country Bank account has paid $397.30 more in interest than Citibank account did. Any questions about that? Good. All right. Next one. This is number 12. Kurt wants to have $25,000 in an investment account 4 years from now. All right, so 4 years from now, he's looking to get $25,000 into an account. The account's going to pay 0.2% interest per month. 0.2% per month, not annually. So that's important. If he saves every month, starting 1 month from now, okay, here's today. 1 month from now is here. This is going to be 48 months that he's going to save for, right? And that's really important language here, is that he's saving money every month starting 1 month from now. That means it's an ordinary annuity. All right, so that language is extremely important. So he's starting to save 1 month from now. How much will he have to save each month to reach his goal? So that's basically asking, what is this payment that he has to make? And he's doing it 48 times. All right, so this is a payment question. So I'm going to go equal PMT, open parentheses. The interest rate is 0.002 per month. So that's already in periodic form. I don't need to divide that by 12. They've given it to me exactly like I need to put it into Excel because I want a monthly payment back out as my answer. The number of payments he's going to make is going to be 4 years times 12, which is 48 months. And then the present value is, sorry, no present value at all. We're looking for a future value, which is 25,000. Close that up. His payments that he's going to have to make are $496.75, which is answer A. Any questions? That was an example of an ordinary annuity payment. All right, number 13 says Slaughter Industries just signed a sales contract with a new customer. What's the contract worth? I presume today. Oh, sorry, no. Worth as of the end of year 4. Okay, we got to pay attention here. If the following payments will be received and the firm earns 6% on its savings. Okay, so on my timeline, it's going to be a cash flow of 84,000 in year 1. Year 2 is 113,000. Year 3 is 125,000. And year 4 is 130,000. Interest rate is 6%. And the question is to actually find a future value at year 4. So this is very similar to that, I think, first question we did. It's a mixed cash flow. None of them are the same. It's a future value computation because the question is to the right of all of the numbers. And so I'm just going to put this straight into Excel in a table form. I really have no other choice but to do it in a table form. So here's my time, my cash flow, my rate, my number of periods, and my future value. Time period 1, 2, 3, 4. Cash flow is 84,000. Whoops, not that much. 84,000. 113,000. 125,000 and 130,000. Interest rate 6% for each one of the cash flows. And then the number of periods forward, since we're valuing at time period 4, this first cash flow is going to be moved forward 1, 2, 3 times. So that NPER will be 3. That second cash flow is going to be moved forward 2 time periods. So that's going to be a 2 associated with 113,000, a 1 associated with a 125, and then 0 associated with 130. Then I'm going to calculate future value. That's going to be equal future value. Open up the parentheses. Interest rate is 6%. I'm cell referencing. Number of periods is 3. There's no payment. Present value is 84,000. All cell referenced. So I can just copy it down and sum it up for an answer of $489,512.14, which is answer E. All right, number 14. You've been told that you need $25,600 today in order to have $100,000 when you retire in 35 years. So we have been told that you need $25,600 today in order to, in 35 years, have 100,000. Oops. One more zero there. Assume interest is compounded annually, and let's see. The question is, what is the interest rate? And I'm assuming that is annually, and it says compounded annually. So the math behind that is take your annually compounded interest rate should be equal to your future value over present value, all raised to the 1 over n times m minus 1, which would give me 100,000 in the numerator divided by 25,600 in the denominator, raised to 1 over 35 minus 1. And in Excel, it's going to be easy. Just hit equal rate, open up the parentheses. Number of periods is 35 years between these two numbers. There is no payment, no annuity payment. Present value, I need to make sure it's a minus sign, and it's 25,600. I need to pay attention to the signage here, and the future value is 100,000. There's no need to put a type or a guess in. That answer is going to be rounded off too much. You can see here the answers are 2 decimals out. So I'm going to make sure that I have enough decimals in there to actually see the correct answer should be 3.97%, which is answer A. Number 15 says Janice plans to save $75 a month starting today. Okay, that means it's an annuity due. Starting today is language in which you have to pay attention to, in that it is starting at the beginning of the period. So $75 starting today, she's going to save monthly. And this is for 20 years. So 20 years times 12 months in a year is the number of payments she's going to make into an account. All right, she can earn an average rate of return of 5.5% over that entire time period. So this is a, oh, we got another one. Kate's planning to save $80 a month for 20 years. And so we've got 2 timelines here. And the first one's name is Janice up here. She's Janice. And here's Kate. And Kate is, that's $80 a month. And that is, both of them are starting today. So these are both annuity dues. And she's also at a 5.5% interest rate. And it's going to be over 20 years. So both of them have the same length of time, the same interest rate, the same fact that they're both annuity dues. The difference is one of them actually does it $5 more a month.
One of them, the second one says starting 1 month from today.
Oops, thank you. That is an ordinary annuity then. Skipping over that. So this is an ordinary annuity that Kate has. And this is an annuity due that Janice has. All right, so I'm going to go straight into Excel with that. Two differences. One of them is actually paying more a month, but she waits a month to do that. So basically every single payment she makes is going to earn 1 month less interest than Janice. Janice is starting her savings immediately, and she's though saving less every month, but she's going to have every single payment she makes is going to earn interest 1 extra month over Kate. So let's see who turns out better. So let's take Janice here. Janice, and this is over 20 years. So let's do a future value. Interest rate is 5%, 5.5%, and we need to divide that by 12 because these are going to be monthly payments. So they both have a 5.5% interest rate, but we need to put that in monthly terms by dividing it by 12. The number of periods is the same for both of them, and that is 20 years times 12. And then the payment for Janice was going to be, she's going to pay out, and I'm going to put a minus sign there. She's going to pay out $75 a month. There's no present value because we can get Excel to do this really cool by just putting that Janice starts at the beginning of the period. All right. And so when we do that, Excel understands that as Janice is going to make $75 payments starting immediately, and she's going to do that for 20 years monthly, right? So she should have $32,821 in her account at the end of 20 years. Whereas Kate, her future value is going to be, again, 5.5% interest. We're going to divide it by 12 because it's monthly again. She too has 20 years to save, and she's doing it monthly. So we're going to multiply the 20 years times 12 since there's 12 months in a year. Her payment is going to be a minus 80 every month. She's going to have no present value lump sum, but she's going to start this at the end of the period. So type 0. She does do better. In other words, she ends up with more money, but it's maybe not as much more as you'd expect because she's actually paying in $5 extra a month. The difference between the two, $34,850.19 less $32,821.80. Kate does $2,028.39 better than Janice. So Janice is paying in starting now, but $5 less a month. Any questions about that one?
Can you go back to the formula you used for Janice?
Yeah.
Okay, thank you.
All right. Any other questions?
Could we go over some questions I had with Connect the other day?
Yeah.
Okay. Let's see. It was a question. You want me to just read you the question?
Yeah.
Okay. It says at 7.5%, how long does it take to double your money?
Okay. So this one's really easy in a sense that you can throw any numbers you want in. You could put in $100 investment today and a $200 return. In other words, doubling that $100. You could put in $1 for present value, $2, for future value. You could put in 1,000 for one for at time period 0 and 2,000 in this future time period. Whatever you do, the present value has to be half as much as the future value. In other words, the future value has to be double that of the present value. So this is just a number of periods problem. You know, n times m is equal to, and it is natural log of future value over present value, all divided by the natural log of 1 plus r over m. And we can do that, plug in if we wanted to. This is not the way I'd probably do it, but it's because it will take quite a long time. And I'm just plugging in what I know. I would probably go to Excel and I would hit equal NPER, open up the parentheses. The interest rate was 7.5%. That's annually. I heard nothing that told me that the compounding was anything other than annual. So I'll leave everything annual. There's no payment. The future value I can put in as -1, and the present value is -1 and future value is 2. That will work. Gives me 9.58 years. And notice if I change that up and put in -100 and +200, you're going to get the same answer. Or if you did, how about this? I did -$1.50 and $3. Again, double your money. Same answer. So it doesn't matter what you put in as far as the present value and future value, as long as they're double, the future value is double. So I could put in -1,000 and +2,000. I get the same answer.
Okay. So you would just use that same logic because they have another question right after that that says quadruple it. So you
Yep.
just use that same
Same
methodology.
idea, only change that 2,000 to a 4,000.
Why is the present value negative? It's reflecting what you're putting
So
in.
if I put in a positive number here, this is what Excel's thinking. You're bringing in $1,000 today, and then you're bringing in another $4,000 at some time period in the future. That's a cash machine. There's no investment made. So in other words, an investment of $1,000 out today, quadrupling means that turns out whatever. See, I get an NUM error when I put both of them in as positive. Excel can't compute. So it needs to have an investment here. You got to get the signs right. An investment of $1,000 in order to receive back 4,000. Does that make sense?
Yep.
Excel just cannot handle it when it's put in positive. It has to do back with our equation. When we have our equation set up as originally, it's future value equals present value times 1 plus r over m raised to the n times m. Notice present value and future value are on opposite sides of the equation, right? They have to have opposite signs. Make sense to everybody? Because the way Excel does these solutions is they're basically solving math, and it's got to recognize the signage on it. So you have to have an inflow and an outflow. Does that make sense? So think of yourself as an investor, or the other side of the equation is the bank. And their flows are going to be opposite. So I could have put in here, instead of a -1,000, I could have put in a +1,000 and then a -4,000. I still get the same answer. All right, it still computes. It's just from the opposite side. The bank is receiving in $1,000. The bank is expected to pay out $4,000 in 19 years. All right, does that make sense to everyone?
Yep. And I just had one other Connect question, if
Okay.
you don't mind.
Nope. Go for it.
Okay, it says, assume that in January 2017, the average house price in a particular area was 291,600. In January 2000, the average price was 192,300.
Hold on, let me redo my timeline.
Okay, yeah, no problem.
Okay, so let's go 2000 and then 2017.
Yep.
So tell me the 2017 number again.
It was 291,600.
Okay. And then in 2000?
192,300.
Okay.
And then it asks, what was the annual increase in selling price?
Okay, so that's basically the rate here that we're looking for. And so, you know, the rate is going to be equal to future value over present value raised to the 1 over n times m minus 1, which is the same thing as 291,600 divided by 192,300, all raised to the 17 years minus 1. All right, if we go into Excel, we just hit equal rate, open up the parentheses. The number of years between those two dates is 17. There's no payment. Present value is minus 192,300. And the future value is 291,600. All right, so once we have that formula in there, we also want to make sure that we have enough decimal points there. I think it probably wants it in probably 2 decimal points after the 2 points after the decimal point. So I'm going to format it so that you can see that. There we go. Looks like it's 2.48% annually that the house is appreciated by.
And can you just go back to that formula? Oh, wait, no, never mind. I can see it.
How are we doing? Okay.
Good.
So what I figure I'll do on Tuesday is just work problems, more and more problems. So you guys bring me problems. If you have some specific ones, I think I can handle emails by next Tuesday. I've been inundated with emails over advising time period, but I think that's gonna be starting on the decline. And so I can handle some emails. If you have some questions, email them to me and I can work them and for you in class. Any questions about the test coming up? Okay. All right. Well, then I'll see you guys later. And Alvin, you got this recorded?
Yep, I'm about to end it.
Very good. Excellent. See you guys later, and you stay safe and healthy.
All right, you too.
Wait. Hey, do y'all know when the test is on the 7th?
Thursday.
Thursday?
Yep, next Thursday.
Okay, what time?
During our class time. It's going to be on Connect. So I talked to you about it the first of this class. And Alvin's going to be posting up the video if you came in late. But it's going to be on Connect. It's going to be multiple choice. You'll have an hour, 15 minutes starting at 12:30. And then it will automatically submit for you at 1:45.
Okay, and I just have one quick question. How do you solve I'm having a problem with computing APR.
APR is just R. It's just the rate, the annual rate.
Okay.
Like- Yeah, it's just like what we just did the last two questions. So you need a present value, a future value, and then a number of